So Newton's first law states that a body will maintain a constant velocity unless an external force acts upon it. Okay, so that might sound very complicated, but what does it mean? It basically means is if we've got a particle here, and let's say it's traveling in this direction, there's no forces acting on it. I've set it in motion, so it could be in sort of a vacuum. There's no forces at all acting on it. No gravity, no air resistance, no force pushing it along, whatever. There's nothing acting on it at all. It will just keep moving in this direction at a constant velocity. It will never slow down. It will never speed up unless an external force is applied to it. So now, let's say I apply some sort of external force. So all of a sudden, there's air resistance. It reaches this block of air, and there's air resistance. So now, an external force is acting on it. It's air resistance, so it begins to slow down. If there was no external force introduced, it would just carry on infinitely at the same velocity, just same direction, same speed, everything for eternity. So Newton's second law is the resultant force on a body is equivalent to its mass multiplied by its acceleration. So in short, you can just write F equals ma. Okay, so this is its resultant force. Resultant force, of course, force, so measured in newtons. This is its mass, measured SI units, so kilograms. And this is its acceleration, which again, SI units, so this will be in meters per second squared. Okay, a good thing to remember is the resultant force will be in the exact same direction as the acceleration. Okay, so if this ball is accelerating this way, then the force being applied is going that way. Okay, so the most common example of this is we say weight equals mass times gravity. Well, this is a force, it's weight. This is a mass, so easy enough, mass and mass. This might not be immediately obvious, but gravity, acceleration, so this would be 9.8 meters per second squared. Okay, so this applies in other contexts, but this is the most used one at A level. So Newton's third law, when two bodies collide, so when two bodies collide, they exert forces upon each other that are equal in magnitude but opposite in direction. Okay, so that's the sort of formal definition. How you might have heard it before is that every action has an equal and opposite reaction. It means the exact same thing. So a good example of this is if we've got a wall and you have a man leaning against the wall. If the man's applying a force of, let's say, I don't know, let's go with 200 newtons, and he's applying it perpendicularly into the wall, then what stops the man going through the wall? Well, there must be some force acting in the opposite direction that the force is applying to the man, so that must also be 200 newtons. But notice it goes in the opposite direction, so the man's applying force onto the wall, and then the wall applies force onto the man. So we can also apply Newton's laws in vector form. So for example, applying F equals ma to our system here. So we've got a 4 kilogram particle. It is accelerating with a equals 2i plus 3j. Then we can just apply it to each component separately. So F equals ma, well, there's our mass, and this is our acceleration. So what would the resultant force be? Well, it'd just be 4 times 2i plus 3j. So you do this exactly as you would expect. You can imagine this is sort of algebra with I and j as different variables. So times it exactly how you would think. So 4 times 2i, well, that's going to be 8i, and 4 times 3j, so that's going to be 12j. And there is our resultant force.